All right, welcome back, everybody. Just a preface, there's going to be a little bit of a bell's going to ring in the middle of it, so we'll just ignore that and keep moving on. So I'm going to take these notes, I'm going to actually split it up into two videos. I'm going to do one video right now with the square root, and then I'm going to do another video with the cubed root. So I'm going to skip through the notes and come back to the cubed root in another video. Same with the characteristics. So this video is just going to be taking the piece of the notes and graphing just the square roots. So when we're talking about a parent function is the starting spot for your graph. So it's an unchanged graph that just has the basic characteristics that are not transformed at all. So if I'm looking here, this is a basic equation for a square root. So if it's a square root, your index is going to be a 2, but it's not going to be written, it's going to be open. Your starting spot is always going to be 0, 0. So with a square root function, if my starting spot is 0, 0, the easiest way to do things is to make a chart. So if you ever get stuck in math with graphing, make a chart. So y equals the square root of x is what I'm graphing. So if x is 0, the square root of 0 is 0. So my y has got to be 0. Now, if we remember, taking the square root of a negative is not possible without using imaginary numbers, so I don't have any negative solutions here. So my next one, my perfect square is 1, because the square root of 1 is 1. The square root of 2 is the square root of 2, so it's a decimal. So I'm not going to look at that with graphing. I'm looking for nice, good, whole numbers. So my next perfect square would be 4. So the square root of 4 is 2. Right there is a good one. If you want to do a next one, the square root of 9 is 3. But that usually starts getting big numbers because that's stretching a graph pretty far. So we're looking at this. This is going to be my basic parent function chart that I'm going to use to graph. So this is a great starting spot for you. And we're going to come back to all these characteristics later. So all I'm looking at today is graphing. So in transformations, if I look to the right, you have your equation that's being transformed. So f of x equals the square root of x. Look at it, that's what's in the black, the bold. And that's what we're dealing with. Now, a couple different things here. H is on the inside, that's your horizontal translation. Remember in our quadratics, that's moving it left or right. Since it's under the radical, it's just like being in the parentheses in quadratics. It's opposite of what it looks like. So it's x minus that number. So if it's an x minus 5 under there, it's going to move to the right 5. X plus 5 is going to move it to the left 5. So it's opposite of what it looks like. Vertical shifts on the outside, it's a plus out there, so it's the same thing. So if it's a minus 3 on the outside, it's going down 3, plus 3 is going up 3. And then that A in front is your vertical stretch or compression. If your A, the absolute value of A is bigger than 1, it's a vertical stretch. It's going to stretch it top to bottom, pulling it up. If it's a fraction between 0 and 1, it's a compression. It's going to get tighter and smaller. If it's a negative out front, that is your reflection across the x-axis. I got one example that I'm going to do all of those with, and I'm going to show you how to make an easy chart here. So if I'm looking at a couple of examples here, today I'm just going to do square root. So my parent function is y equals the square root of x. I'm going to look at my different transformations here. So this is going to be a plus 4 on the inside. So that's going to tell me I'm going to go left 4 units. I got a minus 1 on the outside. So that's going to go down 1 unit. So what that tells me here is that my starting spot was 0, 0. It's going to go left 4 and down 1. So my new starting spot is actually going to be negative 4, negative 1. Now, what I've seen in my years of teaching, it's a lot easier for people to build a chart. So 0, 1, and 4 are my x values. 0, 1, and 2 are my starting y values. I got that if you look back at the parent function right here. That's that boxed in chart. I'm going to do that every time. This also helps out, building a chart helps out with your organization. So left 4, I'm going to subtract 4 to every x. Because I'm shifting it left. I'm just subtracting and I'm moving it left 4. Down 1, so I'm going to subtract 1 from every y. And that's going to give me a new chart for my new graph. It's going to shift everything. So negative 4, negative 3, and 0, negative 1, 0, and 1. So if I plot those points, I'm gonna have everything. So let's look at this, 0, 0, 1, 1, 4, 2. This is my parent function, so y equals the square root of x. My new function that I just got, my new chart, I got -4, -1, I got -3, 0, and I got 0, 1. This is my new graph. And if you take a look at it, the shape didn't change because there's no stretch. It's no reflection. All I'm doing is taking each point. My only transformations were left 4 and down 1. So I'm taking each point, I'm going left 4 and down 1. So if you see, you got 1, 2, 3, 4 and down 1, so I'm good. 1, 2, 3, 4, down 1. 1, 2, 3, 4, down 1. So you could draw your parent function and count them all over, or you can go the chart way and get you points. So either way is fine, whichever way you like it. I like the chart way when it comes to stretches and compressions and stuff like that. But yeah. All right, back at it. So I had a little interruption. So let's look at another one with just translation. So we're just gonna slide it. So my parent function here, once again, I'll try to keep it the same, square root of x. So starting spot would be 0, 0. But I have a couple of transformations. So -3 on the inside, so that's gonna go right 3. Plus 6, that's gonna go up 6. So if I build my chart, perfect timing, 0, 1, 4, 0, 1, 2. I'm gonna go right 3, so I'm gonna add 3 here. I'm gonna go up 6, I'm gonna add 6, which is probably gonna get off the chart a little bit. And then my new chart, when I simplify, I got 3, I got 4, and I got 7, I got 6, I got 7, and I got 8. You can kind of see the numbers should go up and stuff in the same realm. So 0, 0, 1, 1, 4, 2, parent function. I like to see that so you can see it. You just kind of a help. Now everything's going right 3 and up 6. So my starting spot becomes 3, 6. And then I got 4, 7, which is over here, 6, 7, and 8's up here. So just kind of a sketch as to what's going on. Cool? Once again, if you got questions, let me know. I'll be glad to help you out. Cubed root, cubed root, cubed root. We will touch those later. Here's the last one for the square root. Today, and you see here, I'm going to add in that -2 in the front. So I'm going to show you how we solve this problem, because order does matter in how you graph. Some people get confused. Do I multiply before I add, or do I add before I multiply, so on and so forth. So here's a great way to combat that. So square root of x, same thing. My original starting spot would be 0, 0. So let's look at what I got. So same thing, -4, that's going to go right 4. Then I got an up 1. Now out here I have this -2. So that's a vertical stretch by 2, and it's also a reflection over the x-axis. That's where the negative comes from. So the negative tells me it's going to reflect. The 2 tells me it's going to stretch. So you'll see that when I get there. So let's go ahead and build my chart. Let's look at this. So 0, 1, 4 for my nice x's, 0, 1, 2 for my nice y's. Right 4 affects the x, so I'm going to add 4 each time. Now, with this, I'm going to take this, I'm going to multiply it by the outside number, so I'm going to times it by -2 first. So that's going to change my shift, and it's also going to change my reflection. So I want to multiply that first before I translate it. Your translation is last, so it's order of operations. So I'm going to multiply before I add or subtract. So I'm going to multiply, and then I'm going to add 1 to them. So that's going to give me, for my final graph, yeah, I'll be close enough. So I got 4, I got 5, and I got 8, which is nice. So 0 times -2 is 0, plus 1 is 1. 1 times -2 is -2, plus 1 is -1. -4 plus 1 is -3. So that gives me a nice, easy chart to graph. So instead of 0, 0, I'm going to start at 4, 1, which makes perfect sense. And let's look at our sketches. So 0, 0, 1, 1, 4, 2, parent function. solution. So 4, 1. Well, that's not right. 4, 1 is up top. 5, negative 1. And 6, 7, 8, negative 3. So it's down here. And you can see right here, it's a reflection. It's going down now. That's perfect. Translation over 4, up 1. And it's a stretch by 2. So you see how each one's twice as high. So it's instead of going over 1, up 1, it's going over 1, down 2, which is perfect. I should go over 1, 2, 3, 4. Instead of 2, it goes down 4. So that's perfect. Multiplying it out. So I think that chart method's the easiest way to keep things organized. Takes a little bit longer, but it's worth it. All right, last thing, kind of run through this. Look at the first two. Using a description to write a function. So I'm going to start with a parent function and add things in. So if I'm going to stretch it vertically by a factor of 2, that goes on the outside. Reflecting across the x-axis, that just makes this negative. And translating 3 units left, it's going to be opposite. Left and right are on the inside, and we're good to go. Just kind of filling in your transformations. Square to x. Reflecting across the x-axis, that's a negative on the outside. 3 units left, that's on the inside. So left is a plus 3, just like we did above. And then 2 units up, we're gonna add 2 on the outside, and we are done. So it's just kind of knowing where to place things. Reflections and stretches are on the outside and the front. Left and right are the inside, underneath the square root, and they're opposite signs of what they're supposed to be. And up and down on the outside, and they are the same. So I hope this helps. If you got questions, let me know. And we'll get rolling. So I hope you have a great, wonderful rest of the day.